Hi there. This video is an exam paper walkthrough of the Edexcel GCSE Mathematics Higher Tier Paper 2 from summer 2023. This paper is worth 80 marks in total, and this is the third video of 4. It will focus on questions 13 to 17, which account for 18 of these marks. Edexcel Paper 2s are calculator papers, so a calculator should be used. A little disclaimer: there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 13. ABC is a triangle. So ABC is a triangle. Calculate the size of angle BAC. So BAC, so this is the angle that we're aiming for. Give your answer correct to one decimal place. So this isn't a right angle triangle. So what we would do here is we would either use the cosine rule or the sine rule, depending on the information that we have. So we're trying to find this angle here that's enclosed by these two sides. We would use the cosine rule if we knew that side length there. We don't know that side length there, so we're not going to use the cosine rule, we're going to use the sine rule. And I'm only going to use two parts of the sine rule, so A over sine A equals B over sine B initially. Now what this means is I use the angle in the opposite side. Well, that means I'm going to have to start with this angle here, because I've got the opposite side here, and then I've got an angle on an opposite side. So I'm going to have to use this information to find the angle at C, and then I can use the fact that this is a triangle to find the angle at A. So let's substitute in what we know. We're trying to find this angle. So the first thing I'm going to do is I'm going to flip the sine rule upside down because I'm finding an angle. So we're going to do sine of the angle at C, which is Y, over 15 equals sine of the angle at B, which is 70 over 18. So to find sin C, I would multiply by 15. And then to find C, I would do the inverse sin of everything on this side. Okay, that would give me the angle C. Now what I'm actually not going to do is work that out. You can, if you want to, stick it in your calculator and work it out. But I know I'm going to take that angle and this angle away from 180. So to find angle BAC, I'm going to do 180. Subtract that 70, subtract this here, so subtract sin to the minus 1 of 15 times sin 70 over 18. It just saves me some time doing it this way, because if I'm confident with my calculator skills, I can type it all in. So we have 180, subtract 70, subtract sin to the minus 1 of 15 times by sin 70 over 18, and then let's close that bracket. So that tells us that angle BAC is 58.45681.063. We want one decimal place. That 5 is going to round the 4 up, so it's 58.5 degrees. Question 14. Show that the algebraic fraction can be written in the form here where A, B, C and D are integers. So A, B, C and D are whole numbers. So we've got a quadratic equation on the top and the bottom of this fraction. So we're going to factorise both of those quadratics and then we can simplify. So if I factorise the numerator, I want two numbers that multiply to give me -6, add together to give me -1. So that could be 1 and 6, 2 and 3. Well, 2 and 3 have a difference of 1, so let's pop them in. I want a -6 and a -1, so it'd be +2, -3, because +2 times -3 is -6, and then +2 subtract 3 is -1. So now I need to factorise the denominator. Now one of these equations is going to match, one of these brackets, sorry, is going to match, so that's a helpful thing for me. So two numbers that multiply to give me -3 add to give me -5, but one of them is going to get multiplied by 2. So we're definitely going to have a 2x and an x. So -3, my only options are 1 and 3. So let's think about this carefully. I'm aiming for -5, and one of these numbers here is going to get multiplied by 2. So I'm going to put 3 there and 1 here, because 2 times 3 is 6. And then the 1 and 6 have a difference of 5. I want -5, so it's going to have to be +1, -3. 2 times -3 is -6, add 1 is -5. 1 times -3 is -3. And then I have a bracket that matches. So this is this algebraic fraction fully factorised. Now I can cancel out that common factor on top and bottom to leave me with x add 2 or divided by 2x add 1. A is 1, B is 2, C is 2, D is 1. They're all integers, they're all whole numbers. Question 15. Here are the first 4 terms of a quadratic sequence. So that's important. We've got 3, 9, 17 and 27. Find an expression in terms of n for the nth term of this sequence. So let's find that first difference. So from 3 to 9 we add 6, 9 to 17 we add 8, 17 to 27 we add 10. Now we need to find the second difference. That's the difference between the differences. So from 6 to 8 we add 2, from 8 to 10 we add 2. So we're going to half that second difference, and that tells us we have 1n squared. So I'm going to generate that n squared sequence now. So we've got 4 terms, 1, 2, 3, 4. So first term, second term, third term, fourth term. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. And now we're going to see, we're going to compare this sequence with the sequence that we're aiming for. So if I write this down here, we've got 3, 9, 17, 27. So to get from n squared to our sequence from 1 to 3, we add 2. 4 to 9, we add 5. 9 to 17, we add 8. 16 to 27, we add... Maths. 11. So... now let's find what we're doing, what the rule is for this difference between our n squared and the sequence. So 2 to 5 we add 3, 5 to 8 we add 3, 8 to 11 we add 3. So we're going to have 3n added, and then to get from 3 to 2 we take away 1. So our nth term is n squared plus 3n take away 1. Question 16. The histogram gives information about the number of hours some students used their phone last week. The histogram is incomplete. So we have frequency density, number of hours the phone was used for. It tells us 28 students used their phones for between 30 and 40 hours. So for between 30 and 40 hours, this bar represents 28 students. So 28 between 30 and 40. Then it tells us that 24 students used their phones between 40 and 60. So for the last section here of the histogram, use this information to complete the histogram. So to be able to represent these 24 students as a bar here, we need to know what the frequency density scale is. Now I know that this bar is worth 28 students. So what we would have done is the area of this bar represents those 28 students. So if I did 28 divided by this class width here, so 28 divided by 10 tells me that that's height of that bar must be 2.8, because 2.8 times 10 gives me that 28 people. So if I follow across here, this is 2.8. So if that's 2.8, let's see if we can figure out what this scale goes up in. So we've got 10, 20, 28 small squares there. So there's 28 small squares. Each small square must be 0.1. So that means that is 1, that is 2, 3, and that would be 4. So 24 students use their phones for between 40 and 60 hours. The class width between 40 and 60 is 20. So 24 divided by 20 gives me a frequency density of 1.2. So this bar is going to go up to 1.2 and it's going to spread across the whole class width from 40 to 60. So that's part A. No student used their phone for more than 60 hours. Work out the total number of students. So we know this bar is 28, we know this bar is 24. So now we're going to work out the area of these two sections of the histogram and then we can add them all together. So from here to here is 10 and then up to there. So this is 3. So this must be 3.6. So 3.6 times 10 is 36. And then across here is 20 and then up to 1.6. So 20 times 1.6 is 32. So that's how many people the bars represent. So let's add those together. So 32 plus 36 plus 28 plus 24. 120 people in total. Question 17a. Show that the equation x to the power of 4 subtract x squared subtract 5 equals 0 can be written in this form. So this is an iteration question, and to write it in this form we're simply rearranging this equation here. But we need to rearrange it in a specific order to make it look like this. So let's have a look at the differences. So it's ending up with a 4th root. Now the only way we're going to get a 4th root is if we're doing the inverse of the 4th power. Well, the 4th power is here on x to the power of 4. So what must happen is these terms here move across first, and then the last step is to do the 4th root because everything's inside that. So we have x to the power of 4 subtract x squared minus 5 equals 0. So the first thing I'm going to do is add 5 to both sides. Then I'm going to add the x squared. Remember, you're doing inverse operations when you rearrange. And then the last step would be to do the 4th root of everything that's on the right hand side. Part B. Starting with x0 equals 1.5, use the iteration formula, which is here. It's this formula, but they've used iteration notation 3 times to find an estimate for a solution of this equation. So what this iteration formula tells us is we use the previous term to find the next term. So the previous term is n, the next term is n plus 1. So if I've got x0 equals 1.5, that's the previous term, and I can use that to find x1. So what I'm going to do is the 4th root of the previous term squared add 5. So let's do that on our calculator. So the 4th root of the previous term squared add 5. So that's 1.640909017. Now to find the next one, it wants me to do it 3 times. So I'm going to have to do it another 2 times. But what I'm simply going to do, rather than type it all out again, I'm going to go back on my calculator. I'm going to enter in the answer button here where I would put the previous term. So there's my answer button. So now it'll use the answer that I had stored previously. So that's 1.665398002. So then to get the next one, I simply press equals because the answer button's in there. So that's 1.6697630888. So it wants us to use that iteration formula 3 times, 1, 2, 3, to estimate a solution. So what we're going to look at now is these answers. So we've got 1.64, 1.66, 1.66. Now I'm going to look at these last 2 in particular because they are the same after the decimal point until we get to that 3rd decimal place. But what you'll notice about that 3rd decimal place is they're 5 or above in both solutions. So what I can say is an estimate for the solution would be 1.67 to 2 decimal places because each of these 2 rounds to 1.67. So I'm going to write 1.67 on my answer line there.